afternoon. Welcome to the British Council Culture Connects Us webinar series. My name is Saman Imtiaz and I welcome you to today's discussion on emerging sciences and new disciplines in science and technology, engineering and information technology. We are honored to have with us distinguished academics and presenters. From Manchester Metropolitan University, we have Dr. Carl Dever and Dr. Eric Liu. From University of Portsmouth, we welcome Dr. Mo Ada, and we are honored to have with us Ms. Brigita Darminto, an inspiring Indonesian student and professional currently pursuing her DPhil doctorate degree at University of Oxford. Before we begin, we'd like to share a few house rules for the webinar. Today's webinar is being recorded. There will be a question and answer session at the end after the three presentations. We invite all of you to please share your questions for our presenters by typing them out in the Q&A box. You will see the Q&A box on your screen at the bottom of the screen, and you can type out your questions, and all our presenters will be sharing their answers at the end of their presentations. At the end of the webinar, on conclusion, we will request you to please share your feedback by clicking on the link that will be visible on your screen for your thoughts, and they will help us design future webinars for you. I now introduce our presenters from Manchester Metropolitan University. We have Dr. Carl Dever. He's the academic lead on Industry 4.0 and a reader in industrial digitalization with extensive experience in research for Industry 4.0 activity and innovation. He's also joined from Manchester Metropolitan University by Dr. Eric Liu. He's a reader in project management with research and development interests in project management, sustainability, environment planning, and IT management within built environment industry. Their presentation today is on bridging the Industry 4.0 skills gap, the pathway towards your industrial digitalization future. Dr. Deva, Dr. Liu, I request you to please share your screen for your presentation now.
Good morning or good afternoon from Manchester. Assuming you can hear me okay?
Yes, we can hear you and we can see you. Thank you.
Okay. Yes, and also good morning, good afternoon. My name is Eric. So together with Carl, we'll be presenting this session today.
So is our screen visible at the moment?
Yes, it is. Thank you.
Okay. All right, all good. All right. Good morning, everybody. So welcome you to this session this morning and this afternoon. Myself and Carl will be delivering this session entitled Pathway Towards Industrial Digitalization, your Future. So what we're going to focus on today is a lot on Industry 4.0, what it is, what it's been shaping into, what is going on in your country, Indonesia, as well as things that we are preparing students towards to bridge the skills gap, to be honest. Next, please. So to start is Manchester Metropolitan University is one of the largest universities in the UK. We have about 300,000 alumni. Our graduates get employed or go into further education within 6 months, so 93%, which is a big number. And we are investing in the campus. So we know what's going on at the moment. However, our projects, our investments in new buildings continue. So within science and engineering, we are continued to proceed with our new build. It should be completed in about 2 years' time, and we are excited about that, the new labs and everything else. At the same time, this picture presents a very important place in Manchester itself. The round building, which you can see, is our Central Library in Manchester, a Grade 1 listed building. This library is important because this is the first building in the UK to be digitalized. This is done about 3-5 years ago. Something called information modeling. Not only we want to model it as a very nice render, a nice picture, but as well we want information into it. Once we have enough information into the building, only then we can maintain it. And all these is way advanced on what we are facing today called Industry 4.0. At the same time, towards the left, the brown building is the Midland Hotel. This is where historically the company Rolls-Royce began. So this is where Mr. Rolls met Mr. Royce, one an entrepreneur, one an engineer. They know themselves that they can't succeed on their own. Hence, when they work together, they started the company Rolls-Royce, started with the cars, and so now we have the engines and engineering firm. So we have the legacy in Manchester, and we have the future in Manchester as well. So we have a very strong base on what we want to do in terms of Industry 4.0 and the way we want to look ahead. Next, please.
So Manchester is seen as the birthplace of the first industrial revolution, where we saw steam and mechanization come to the fore. And then I'm not going to dwell too much on what happened previously, but just go through it quickly. And then around 1870, we had the second industrial revolution, where we saw electrification coming in. And people think it might have been kind of Henry Ford and the kind of Ford Motor Company, but it actually was a slaughterhouse in Cincinnati, which was quite grim. But again, it was about increasing productivity. And then around 1970, and we see a pattern here nearly every 100 years, we saw the numerical control starting to come in. So numerical control of machine tools on shop floors. But now we're living in the fourth industrial revolution, and I'm not sure if the camera's picking up, but most of us have one of these smartphones, and it's all about connectivity. It's about bringing the physical world and the virtual world together. And again, like the previous industrial revolutions, it's about having information, being more productive, and using your resources efficiently. So we're living in a really exciting period at the moment. And okay, it's fine for me to say that, but others are saying that globally as well. And I think in Indonesia, you have Industry 4. Make Industry 4.0 or Made Industry 4.0. So every country has their own type of program around Industry 4.0. So, you know, $14.2 trillion to the global economy by 2030. 35% of companies adopting Industry 4 expect revenue gains in the next 5 years. 67% of UK manufacturers recognize there's an opportunity. In the UK, we had a review of industrial strategy a few years ago, and they see a 25% increase in productivity. And now we have made smarter programs, investing, helping companies digitize, adopt those digital technologies. So there's a real opportunity here. And for us as a university, we're reacting to that to see what can we do to help industry, but also to help students and graduates coming through. So we're looking at how we can bridge that skills gap, bringing the next generation of students through, but also helping reskill existing people in companies and listening to industry and what their needs are. So we're bringing those two groups together and bridging that Industry 4 skills gap. And historically, there's since around 2012, I think, or 2011 was the first time the Industry 4 term was coined at the Hanover Messe in Germany. There are different pillars related to Industry 4.0, and it touches many aspects of our daily lives. And it's not just engineering, but it crosses many sectors. So things like the Internet of Things, cybersecurity, cloud computing, additive manufacturing or 3D printing, augmented reality, big data, many aspects where we can bring digital technology into areas, connecting everything so that we can have better visibility, and going back to that point of efficient use of resources, being more productive. And it brings us to digitalization. What is digitalization? So we hear this term industrial digitalization, but for me, it's very much, about that connectivity of different aspects of business. And when we look at manufacturing, it's a really exciting time. So we're bringing, that whole digital workflow from concept to design to manufacturing to how products are used, so we can learn from that and what happens at the end of life. But as I said, it's not just about engineers. It's also an opportunity for artists in the creative sector to start looking at how can digital technology help us, and especially healthcare as well. How can we learn from the information and knowledge that we have around healthcare to improve life expectancy, things like that. And a good example of, and Eric will probably touch on it in a while, an MSc in industrial digitalization that we put together a few years ago. This brings together people from many different backgrounds. They don't just have to be engineers to work together in a creative space. And this is a project that I supervised with 3 students on that recently for Lacoste, which is quite a famous sportswear brand. We were looking at how can we improve footwear for ankle injuries. And to do that, we started looking at 3D scanning people's feet, embedding sensors within that, and then using a package from Autodesk called generative design to try and optimize what the core design of the shoes should be. And then looking at that, we start developing how do people move, and customization and personalization of products is something that we're going to start to see more and more of with Industry 4.0. I think this is a perfect example of bringing many different aspects and people with different backgrounds together to try and find a solution. So I'll pan back to Eric now on this one.
Yes. So another way of looking at digitalization is new build construction. So the construction industry is one of the largest industries that we have of today. So what we have this model right here is some will know or call the information modeling, but from a desktop kind of a model, we bring it to a mobile segment at the moment. So this is a new build in Manchester in the National Graphic Institute. This is the model. We can see the completed building right here is in dark brown in color. And if you go to what happened when do construction during the modeling times, there is the whole video. That's how the thing started. So we can bring all these things together, and then we can all bring this up in mobile. So it brings up 2 things. We increase productivity, we start to increase the efficiency, and at the same time, we're able to model the building. We can now see the model in the computer before we built it. And because the labor cost in the UK is so expensive, we want to minimize time on site. So these all help in a way, okay? So this is a simple BIM model mobile that we can do. Another concept that we have right here is next car, is the Blue Mansion. So those who are in Malaysia, in Penang, this is the Blue Mansion or Chong Fat Si. This is one of the most historical buildings that we have in Penang, and it won lots of awards. We want to digitize this building, its heritage side of it. So we use laser scanners, we go to live stream, and then when we scan the building, we get to know this building a bit more. And you can see various pictures into it. So we've got an aerial view at the moment. We get views on different segments. I could start to remove roofs, for example, to see in the roof truss. We can move in a bit more. We can see the ground floor. We can see the floor plans. At the same time, I mean, laser scanning in a way is good visualization, but we can't make it clever. That's the problem. So we can only scan what we can see. And then there are some black segments. Same thing in Penang. This is Ku Kong Si, another very historical building. What we, again, try to digitize it, but what's happening at the roof segment is very hard to digitize. And this is what we get in generally one scan, laser scan. And then if you go towards the next, and this is what you could see. But if you look right at the top of the roof, it is very difficult to digitize. One may ask, why digitize it? Simple answer is preservation. At the same time as at the world we live in right now, we want to recreate. So there are different segments within heritage. Some are very staunch historians. They want to make it the same materials. Some have said, let's model it, let's print it, and let's replace it. There are 2 ways of looking at historical objects at the moment right now. So in terms of Penang, there are too many historical buildings. Number what they want to do now is to keep it at the same time to preserve it. Next one.
Okay. So I mentioned the 9 pillars of Industry 4.0 previously, and one of the exciting things at Manchester Metropolitan University is that we see many of these pillars, activities related to these pillars happening across the university. So, and it's something that really excites me about the university. It's not just in engineering, it's across business, it's across in architecture. We have, the Manchester Cyber Foundry looking at cyber security. We have the Institute of Coding that's helping to train people around data and analytics and programming. We have the Manchester Fuel Cell Innovation Centre looking at emission-free energy. We have Print City looking at additive manufacturing. We have the Advanced Materials and Surface Engineering Research looking at new materials. Crime and Wellbeing Big Data Centre, using big data with regards to crime. We have Future Economies Research Centre looking at the impact on the economy of all of these new technologies. We also have the Manchester Fashion Institute which again is vitally important when we start looking at personalization and customization, and having clothes that fit. And with fashion being one of the second largest polluter on the planet, there's a real amount of work that needs to be done here on making sure we're not overproducing. And with regards to that, with all of that activity, we're working with many collaborators, very famous companies that many of you will be acutely aware of. And Autodesk is mentioned there. That's, there's a real collaboration between our Print City facility, which has over 60 3D printers, 8 different technologies. And we've recently received around £3 million in funding to invest in more 3D printing equipment for small and medium-sized companies in the Manchester region. So you can see we're really working with industry. We have the research and teaching going on, and it's bringing both of those together, as well as the local government stakeholders. So listening to all of those people all of the time to make sure we're doing the right thing for the right people to bring technology forward. And one of the things we did, we should have done one in April this year, but due to COVID, it was postponed. But we brought all of our academics and these are the students on the MSc in Industrial Digitalization, to this large trade show, which ran over 2 days, and an opportunity for students and academics to get out there, to meet people, to develop those soft skills that are really important as well as the core fundamentals that we teach. So I'll hand back to Eric now.
So I mean, towards students' pathway in digitalization, what Carl mentioned is this interdisciplinary subjects. The concepts are very important to us. So we start right to the top of industrial digitalization. So basically here is that we welcome all students from any discipline, whether if you're in fashion or you're in chemistry, chemical engineering. In industrial digitalization is that this year where you can try to digitize your analog world, model it, and to print it. There's a whole process you will learn about within this program. At the same time, we also offer 2 very specialized programs in electrical and electronic engineering, so as mechanical engineering. We have the 2 core engineering with us. At the same time, and to pull it all back together, we have the engineering project management. Here is where we try to get everyone together and how to manage engineering projects. As what Carl did mention, soft skills, the management side of it is always lagged behind. Everyone keeps thinking that, Chrysler building or anything else is built with one day. No, it is clever management to make it happen. We can see all sorts of problems these days with our airplanes. So Boeing's having lots of problems. When Boeing traces back the issue, it is not a technical issue, it's a management issue. Because why? Some parts of it are not done in the right way. So the formalization, the planning is not in the right place. So what's missing is a lot in the engineering project is how to manage them. At the same time, with our 2 master's programs in engineering, we are offering a 1-year placement for the students. So basically, students will complete their master's with us, and then they can spend another 12 months in the company to complete their placement. Obviously, this provides this opportunity for students to apply their skills. At the same time, they're able to join a company for 12 months. Should be based around Greater Manchester, and because we're partnering lots of companies around Greater Manchester, at the same time you get the larger ones and you get the smaller ones. So it's an opportunity for students to actually apply what they know into industry as well. A bit focused on the industrial digitalization. As I said, we built this course to what industry wants. As I said, the partnerships with industry is very important for us. We are preparing you for a new career. So whatever background you come from, I did say, I mean, if it's manufacturing or if you're in dentistry, we are trying to digitize that environment. The ability to digitize the analog world is a challenge. So I did demonstrate earlier on the built environment. How do we digitalize our heritage buildings and, make it happen? Once if we can digitize it, we can able to run simulations. Only then we can bring in all the sustainability tools to make your buildings more sustainable. In the UK, for example, Grade 1 heritage buildings is a big problem. What we have is single glazed windows, and it takes a lot of energy to heat up the building. At the same time, regulation says you must always have single glazed windows. So how do we work with different disciplines, bring them all together? It's what the industrial digitalization is all about. Okay, next. At the same time, we recognize that, okay, we don't live alone. We are, I mean, myself and Carl is from engineering, but we work very closely for people from computing as well. So there is a lot of focus on cybersecurity, which I think the next colleague will talk about. At the same time, not only that, so analytics is another big tool. So how we see how Tesco's today is still being UK's #1 grocer. Why? They are prepared for it. They employ a lot of data scientists and analytics to make sure that they get the stocks correct. Once we got it right, once they know the data, they know what's going on, we can analyze it. Only then they're able to unlock the power of being the right grocer, the right price, the right time, no wastage. Okay. At the same time, is that we did talk to colleagues within this program called MSc Computing, whereby they're able to take in students from any discipline. So if you're trying to do a conversion program, if you are in human resource, for example, who wants to go into computing, this is the program for you. Okay. Next. So just very quickly to finish it is that we don't only focus on the academic side of it. We have a lot of industrial partners with us. We partner Siemens to get the connected curriculum, this industry software. We encourage our students to take a lot of industry qualification like the APM, PFQ, SolidWorks, and all these are industrially recognized software. At the same time, is that our students will get our education, get into Print City as well as our flagship program. We are partnering lots of companies. On the left, you can see these are all 3D printers, hardware, software, Autodesk students will have access to as well.
Thank you so much.
Okay, so just to round it all up together. So, I mean, we have this big programs running around us, but what we want for the students is the ability to work together. I think that's very important. And that's what we miss within the undergraduate program. So the ability for students to come in and to realize that they can work across disciplines and work together with people from different disciplines. I think that's what we want our students to do. Last words, Carl?
Yeah, I think it's just a really exciting time. We're evolving at Manchester, listening to industry, listening to the kind of students' needs, and making sure we're adapting and reacting to that. So looking forward to the questions in the Q&A section.
Thank you so much, Dr. Deva, Dr. Liu.
Thank you, Saman.
I again invite all our attendees to please do share your questions by typing them out in the Q&A box, and we will be requesting our presenters to share their answers based on your queries and your questions, touching on the content of the presentations, the skills gap, the 9 pillars of industry, the way that digitalization is touching all aspects of life now. So please do share your questions, and we will try and take as many questions as we can. I now will invite Dr. Mo Adda from University of Portsmouth. Dr. Adda is a principal lecturer in computing, and he's the course leader for cybersecurity and forensics information technology. His research interests include cybersecurity, digital forensics, embedded systems, big data, and cloud power management, among other areas of expertise. His presentation today focuses on cybersecurity and forensic information technology. Thank you, Dr. Adda. Over to you.
Thank you very much. Good afternoon, ladies and gentlemen, parent and student. I am Dr. Mo Adda, principal lecturer and course leader for MSc in forensic and cybersecurity. I'll be presenting our degrees in cybersecurity and digital forensic that we offer at the University of Portsmouth in the School of Computing. Before I start, let's briefly talk about the University of Portsmouth. University of Portsmouth is located in the southwest, near the sea, about an hour by train or an hour and a half by bus from London. The university actually has got a quite exciting reputations. We have the gold medal for the TEF, which is Teaching Excellency Framework. We are actually #1 in terms of graduate salary boost. You can see actually the reference economic 2017. We are actually in the league as reported by The Guardian, 21st in the league. 97% of our students actually find work after their graduations. And worldwide, we are actually the 5 stars rated as worldwide. I'll be talking actually briefly about the degree actually we offer in cybersecurity and digital forensic, although we do offer actually other programs in software engineering, computer science, big data, data analytic, etc. But I'm going to concentrate today just on cybersecurity and digital forensic. We all actually know the challenge that the internet and all the organizations are facing in terms of security, as actually my previous colleague talked about the Industry 4 and mentioned actually the impact of attack and cybersecurity that could actually influence or interact with the technology itself. So from this diagram, actually, you can see that the infrastructure of the whole world is actually bombarded by criminals and hackers trying actually to steal informations from organizations or actually steal money from banking systems. Now, surely actually, how do we prepare our students to face that challenge and be able to propose solutions for the future? In addition to that, actually, how do our students actually collect evidence when a crime has been committed, and through a process of investigation method, how do we end up in court as expert witnesses to actually convince the juries and the judge actually about their funding that have been collected to prosecute a criminal? Surely, actually, we do that by providing courses both at the MSc level and the undergraduate level, and prepare our students for this big challenge in the future. The objective of the course actually in cybersecurity and forensic computing is actually to prepare students to work as professionals in the field of forensic IT, information technology, law firms, enforcement agencies, insurance companies, IT practices, and cybersecurity organizations. Eventually, the field is very wide, as our recruitment have shown. Our programs, both actually the undergrad and the postgrad, are accredited by the British Computer Society. Also is accredited by the Chartered Institute for IT, Information Technology, and it meets actually the academic requirement for registration as Chartered IT, Information Technology. The postgraduate level goes a little bit further to meet actually the requirement of chartered scientists if their final project is a study project, or a chartered engineer if their final project is undertaken as an engineering project. The cost of the course is actually, for the MSc course, part-time is about £2,600, full-time about £7,800. For international student, the full-time is around 16,000, and the part-time around 5,000. That's for the MSc. For the BSc, for the international student is about 16 again, around 16,000, and for the UK and EU student is about £9,000 per year. The structure of the course for the MSc cybersecurity, it's a one-year course. There are 2 entries, September entry and January entry. In September entry, the student will go through the following modules. They study computer forensic and cryptography, and then they move to mobile forensic, mobile phone investigations. And then in the second block, they will go to cybersecurity, system security, hacking, and then they will choose options from big data analytic, or business intelligence, security and risk management, cloud computing, or criminology. So that's an option to actually enlarge their understanding about the concept of cybersecurity through different other fields. And at the end, actually, they do a project which will be actually during the summer, and they graduate in September. The entry would start in January. They will go straight into cybersecurity, system security, hacking, and then they choose one of the field in big data or data analytics, business intelligence, security management, cloud, and then in the second block, they will do computer forensic, cryptography, and mobile forensic. In a way, the year is divided in two blocks. The first block is about forensic, and the second block is about cybersecurity. The undergraduate is a 3 years program, and the 3 years program actually involve the following. In the first year, all the students will be looking at the architecture, operating system. They need to understand actually how the computer system works to be able to understand the forensic part of it and the cybersecurity part of it. They look at the network, they do a bit of programming, and then the second year, they look at ethical hacking, forensic fundamentals. What is important is in the yellow that you can see that student can take options, and one of the interesting options is called industrial placement. Industrial placement, student will be placed within the police department within the university itself. It's called the high-tech criminal department, where student could have experience, in fact, actually apply the theory into a practical work, and they also get paid for it. So it's good actually to get a bit of money, not a lot, but at least a bit of money from the police, and you will also gain experience. In the final year, the third year also, student will do the malware forensic, more some advanced, a little bit advanced modules. And also they have the ability also to have work placement where they work in the industry related to forensic or to cybersecurity. In terms of teaching, we offer the teaching include the following. It includes actually written assessment, supervised work sessions where students work in groups in the lab doing an investigation, for instance, and they will have to write a report at the end. They also work in seizure simulation where we create a criminal case within the laboratory, and the student will have to find evidence, do some research and analysis on the evidence, produce a report, and take them to court. So we have a court session, and the student will be standing there as expert witnesses to actually provide their evidence to the court. There are lectures, practicals, and also we have several guest speakers that come to the university to present their experience. Most of the speakers, they come from industry, and some of them are ex-alumni or ex-student that actually graduated from the university and have been working successfully in the industry. Excuse me. And they will come and talk to the student about their experience. There are free support. The university provides a lot of support for students during their life cycle of the study. The personal tutor, each student will have a personal tutor. They could talk actually face-to-face, and the personal tutor could advise students, direct them, and support them through their academic studies. We have actually learning support and academic skill support. Also, there are special centers within the university that could help students achieve their objective in terms of helping them how to do critical thinking, how to do presentations, how to write a report, how to write papers. There's also a math cafe as well, another center who could help students actually with their mathematical skills if they do find it difficult to progress through the program. We also have the library support. Library support actually, people are there. They could actually have a face-to-face meeting with the student, and they can help them choose the best resources and books within their subject area. We also have English support for people actually who need a bit of boosting in English. They can go to all these actually support are free for students. In terms of jobs, actually, 95% of our graduate students, they found actually job. And the job actually are within the area of security architecture or architect, if you like, penetration testing, cybersecurity analyst, forensic investigators, e-discovery examiner, business intelligence and forensic with NHS, IO standard validations, banking. So all these actually jobs that are reported here, they were actually updated actually by the students who are graduated, and they keep informing us about their success. The student actually that graduate will receive a continuous career and employability services throughout their graduation time, and also up to 5 years of graduations. So the university can actually help them even 5 years after they graduate from our university. And thank you very much for listening to me. And if you have any question, please do put them into the Q&A. Thank you.
Thank you so much, Dr. Ada. You shared so much about how students can prepare for this very unique specialization, and how this leads to careers across industries, and how the universities in UK continue to support their students in terms of providing professional linkages, professional development, practical hands-on experience. And I again invite and request all our attendees to please do share your questions that you have for forensic information technology and specializations in this field. And we already have our academics and our panelists answering some of the questions in the Q&A box. So please do share more and all of your queries. I will now request our third presenter and speaker for the webinar, Brigita Darminto. She is an Indonesian student and professional. She is currently pursuing her DPhil from University of Oxford, specializing in material science. She has worked as a forward planning engineer for Jaguar Land Rover, and we invite her to share her experiences of her student and professional journey as a student from Indonesia in the UK. Hello, Brigita. I invite you to please share your screen. Thank you. Hi, Brigita. We can see you. Your camera is on now, and yeah.
I'm trying to share my screen now, but I'm
It's
getting
okay.
the options now.
It's all right. There's a share screen button at the bottom of your screen.
Yep.
Okay.
Cool.
Great.
Get it. So, good afternoon to audiences in Indonesia, and good morning to those in the UK. My name is Brigita Darminto. I'm currently a first year DPhil or PhD student in materials at the University of Oxford, specifically in PASTA's group, doing research on battery. Today I'm going to share about my journey in the UK while pursuing education, as well as working here for 2 years, as well as to share my journey towards the topic that I care about, which is the future of renewable energy. So I'll start a bit with a timeline of my time here in the UK. In total, I've been here in the UK for 7 years. I started here in 2013 to do, I came here to do MEng or Master of Engineering in Material Science and Engineering at Imperial College London. And the program itself was 4 years. So it finished in 2017. But in my second year, in the summer, I did an internship at BAE Systems as project management intern in emerging technologies. There, I got to work in the cross-section between material science, software engineering, and project management. And then the year after, I did another internship, but this time at Jaguar Land Rover, a car manufacturing company, as forward planning engineer. And then I really enjoyed the work I did there and got a return offer from Jaguar Land Rover. So I came back to the company after I graduated in 2017. And actually, before I graduated, while I was still at Imperial, I did a final year project on energy storage, specifically on supercapacitor. And again, I really liked the subject and I really enjoyed doing research on energy storage. While doing this, I was actually looking around about opportunities to actually work or continue my work on energy storage after graduation. And I found out that Jaguar Land Rover, or the company that I'm planning to return to, is actually transitioning or transforming most of its cars into electric cars. So I felt like this was a good opportunity. So I decided to come back to Jaguar Land Rover. And then while I was there for 2 years, I realized that I was still lacking of knowledge. And I'm very curious about how people actually came up with the original design of battery that we have currently in the market, and the future of it. Would the design of battery change at any time, or how would this change? So I decided to apply for a PhD or a DPhil at the University of Oxford in materials, and also applied for a scholarship from Indonesia, the LPDP, or Lembaga Pengelola Dana Pendidikan. And thank God I got both. So I decided to stop my work at Jaguar Land Rover, and I started my PhD last year in October at the University of Oxford. So I will start from the very beginning about my journey, about the preparation of how I finally came up to the UK for my undergraduate degree. So my first step is actually to get as much as information as possible and plan ahead. I planned my undergraduate degree from early on during the first year of my senior high school, or grade 10 in Indonesia. At that time, I searched around for information about what universities actually require and about the degrees or the program that I'm interested in. I know I am very interested in mechanical engineering and material science. So I look around for information like what do they require from applicants, like what curriculums do they prefer. And I found out that they preferred IB, or International Baccalaureate, for undergraduate and A levels. So when I actually applied for senior high school, I tried to find high school that provides this curriculum. And also I realized that these are offered in international schools in Jakarta, and these are quite expensive. So again, I look around for scholarships, and finally I found scholarship as well as a good high school in Jakarta, which is called ACS, International School Jakarta, which offered the IB and IGCSE program. So I decided to pursue my high school there. And this helps my application a lot later on, 3 years later, which is in grade 12. And then after that, the second planning that I did with my family was the funding. We asked ourselves, do we actually have enough funding for the undergraduate program? If yes, then go forward with the university applications or the UCAS application. But if not, then again, this is not the end of the world. There are scholarships available, but you just have to go out there and try to find the information. And then finally, when you reach grade 12, when it's time for you to actually apply for university, then you need to set your strategy right. Basically, I think in UCAS, if I'm not wrong, you have 5 options of universities. So put the universities that you really want to get into in there. But at the same time, make sure that you also have universities that you know you will get into because your qualification meet their requirements. Because it's always nice to have some universities some university applications that are successful at the end and you can go to after the end of your UCAS application. And then prepare all your requirements well. Don't be embarrassed or don't feel bad to ask people for help to, for example, proofread your essays, and then make sure you submit your application on time. Finally, it's time for you to get your visa and attend the university. Now I'm going to talk about the subject itself, material science. So what is material science and why I decided to take material science? So material science is an interdisciplinary subject spanning from physics to chemistry of matter, engineering applications, and industrial manufacturing processes. So what are the applications of material science? Where can we find this? Material science is actually used a lot in day-to-day lives, like the lightweight composites for faster vehicles or airplanes, and then optical fibers for telecommunications, including batteries for renewable energy, and even biomaterials like hip replacements or artificial hearts or limbs. And what are the examples of modules that you can take in material science? There are, for example, mechanics of materials, and then engineering alloys, ceramics and composites, nanomaterials, optoelectronics, and biomaterials, like I mentioned before. And how are the job prospects of material scientists? You can work as materials engineer, metallurgist, aerospace engineer, manufacturing engineer, and even banker and management consultant. If at the end of your degree, you suddenly decided like, oh, I want to move away from engineering, that's fine too. And while you were studying material science, usually people don't take a lot of courses or modules or on finance and management, but then there are transferable skills and knowledge that you can transfer to banking or management consulting. So now moving on to my PhD or my DPhil research topic, which is on battery. So what is battery? So battery is actually an energy storage device that converts chemical energy into electric energy when in use, and vice versa, from electric energy to chemical energy when charged. So where can you find batteries? Probably in day-to-day life, you find batteries a lot in your phone, in your laptop, that is the small scale. And then in the medium scale, you have batteries for electric cars like Tesla. And in the large scale, you can find batteries in energy, batteries used in the grid, or it is used to actually bridge the gap between the demand and supply from the renewable energy sector. And according to McKinsey and Company, there is a 90 to 635 billion US dollars potential economic impact of improved energy storage by 2025. And according to Bloomberg New Energy Finance, they predicted that by 2020, there will be 500 megawatts of globally installed large-scale battery power. And this would surge to almost 1,000 gigawatt by 2040, or almost 7% of the world's energy capacity. And specifically in my PhD or my DPhil, so what do I do there? So I'm actually doing research on anti-perovskite solid electrolytes for lithium and sodium metal batteries. Anti-perovskites is the name of the materials. So what are the motives behind my PhD? So there are three of them. First one is to actually create a safer battery and the second one with a longer cycle life. And third one, the final one, is with higher energy density. So why I chose anti-perovskite material specifically? There are four reasons for that. First one, because it is quite easy to synthesize. The synthesis temperature is actually quite low, below 500 degrees Celsius. And then it has wide electrochemical window, and then its properties can be tuned by doping. And then last one is it's quite stable against the metal electrodes, which can help increase the energy density of battery. So how did I end up doing this research? I actually decided to do this research partly based on my experiences at Jaguar Land Rover. There, I got insights from the company or from the industry about what they are actually looking for from their batteries. And then after that, I had discussions with my supervisor and other experts in the field about what materials would be suitable for what they're looking for. And then after that, I also did my own study or my own literature review to find out what other people in the field are actually doing and what materials do they do research on. And then sometimes research or PhD is the PhD topic itself is sometimes, it's kind of like dictated by the body or the institution that gives funding. But then in this case, for me, the LPDP, they kind of like didn't specify what materials I should actually do research on. So how does battery research in the UK look like? As far as I know, currently in the UK, there are two main institutes or institutions that focuses on electrochemical energy storage. The first one is the Faraday Institution, which was formed in 2017. This is an independent institute for electrochemical energy storage, science and technology. Basically, it supports research, training, and analysis, and it brings together people from industry and academia. And then the second one, we have the Henry Royce Institute in the UK. where they actually supports the Faraday Institution universities like Manchester, Oxford, and Cambridge by providing the state-of-the-art equipment for the research. And in total, according to the Faraday's website, they are planning to make serious investments of £274 million by March 2021. And this is very big. And why? Why people in the UK are interested in batteries? Actually, there are a few reasons, but I picked 4 of them from the Faraday's website. So I think there are 3 big opportunities that they see there. Two of the industries that might be affected by electrifications or the use of batteries are the automotive industry and then the aerospace industry. And the UK itself is the 4th largest vehicle producer in Europe, and 81% of all vehicles are exported. And then globally, UK owns 12% share of the global market for aerospace industry. And currently 800 million people worldwide still do not have access to industry, still do not have access to electricity. So these are the 3 opportunities that I think the UK is trying to maximize by being the leader in battery field. And from the resources point of view, UK actually has quite good quality resources or people who can actually help the UK to become the leader, because 4 of the world's top 10 universities are located in the UK. So enough about my research and enough about the education. Now I'm going to talk a little bit about my early career journey. Why I call it early career? Because it's still less than 5 years. I've only graduated from my undergrad 3 years ago. So I've worked in the industry for 2 years and now 1 year in PhD. I would consider the PhD, even though like I'm still a student, but I feel like a PhD itself is almost like a job, because you are responsible for your own research, and then you are no longer taught by the professors. So it's very independent work. So I would call this a job as well, even though it's not really a job. So in total, if you count my PhD as a career as well, in total, it's been 3 years, so less than 5 years, which is why I called it early career. So there are 4 things that really shaped my early career journey. The first one is my undergraduate degrees, like the modules I took during my undergraduate, as well as the projects, like the energy storage project I took as my final year project. And then the second one is the university's career service. The university's career service was really helpful. Whenever I want to apply for a job or an internship, I always go there just to get some ideas or about what what the industry looked like, and also to get feedback about my CV, or to get feedback about my cover letter, or see if the skills and knowledge I have actually fits the job that I want to apply to. And then second one is network. Be it in the field that you are currently in, or for example, if you are in material science, but you want to move to another field for your job, for example, to banking or management consultant, then make sure you have the network for it. And how to build the network? By going to career surveys and join the student clubs and association. Sometimes you might think like, oh, would I actually get something out of the career surveys? Because there are like hundreds of people there. And also, would the people you talk to actually remember you when you apply? Believe it or not, but I actually got my first internship from a career fairs. Basically, I talked to an engineer from BA Systems, and from there I got some insights into the company. And when I applied for an internship there, I could write about what I know about the company and what my conversations with them were, and that what made my application stronger. And the third one is the internships or the work experiences itself. It gave me a taste into the real life cases of engineering, as well as gave me the chance to build my transferable skills for my job after graduation. And finally, it's the long-term goals. You need to ask yourself what you want to achieve in the long term. For me, I know I would like to help support the transition from fuel from fossil fuels to renewable energy sources. And I want to tackle the energy storage side of it. And that's why even when I was working for Jaguar Land Rover, I was always trying to work in the field related to batteries or energy storage. And even now I'm doing a PhD on it. So that's it from me today. Thank you for listening. If you have any questions, I would be happy to answer. Thank you.
Thank you so much, Brigitta. Thank you so much for sharing your student and academic journey and your plans for your future while you complete your current degree. Thank you to our attendees for sharing their questions with us in the Q&A. Thank you to our presenters who have been typing out answers to most of these questions. We have 5 minutes, 5 to 7 minutes for the webinar. So most of the questions that we have received focus a lot on careers and how job markets and job trends will change. There are also questions about what kind of student experiences applicants should expect at campuses in the UK. So I'll share a question. Carl, if you'd like to take this, that we received a question that what would be a game changer? What could be a game changer as far as future technologies are concerned? And how do you foresee the impact on jobs with the current digitalization of everything?
Yeah, thank you. It was a very good question, and it's a difficult one to answer. I think something I probably come back to is advice I probably give people is try and follow something that you're passionate about or that you have a real interest in, because in your career, if you can do something that you enjoy working on, then you'll be successful and you'll want to get up every morning and be enthusiastic about going to work. So I think focusing on that aspect is key initially. I think there's going to be opportunities in many areas. We're seeing a lot happening around artificial intelligence, understanding data and things like that. But we still have to make things. So there's opportunities for people around manufacturing. I think there's opportunities around, especially around creative and the arts. And when we start bringing, all of these things together. So I think in the future, we'll see a lot of kind of multidisciplinary skill sets coming to the fore. So it's important that you have a core focus in one area, but that you develop skills in other areas as well. So if you're a mechanical engineer, then definitely you need to understand the core aspects of that. But it's important to understand how to do some programming and things like that as well. And I see that with my students, that they can't just design something now. They need to learn how to, do some programming on Arduino and things like that. So, yeah, I think, follow something that you're passionate about, and then drive that forward and create those opportunities yourself.
Thank you so much. Thank you. We have a question about cybersecurity and forensic information technology. Dr. Mo Ada, if you'd like to take this question. The question is, what kind of lab work would a student expect to experience as part of their degree?
I have already answered this question, actually. I typed it, but I can go through it again. We have actually 3 type of labs. One for cybersecurity, which support a lot of software tools. They do actually simulation of hackings. They do cryptography, and they do the analysis. We have another lab which we call it usability. In the usability lab, actually, we do seizure simulation, in which case we create a fake scenario involving a criminal performing illegal activities and leaving traces within the machines within the lab. The student actually will have to go into the lab, be able to dismantle the hard disk. We'll teach them how to do that. Dismantle the hard disk, image the hard disk, extract evidence. These are all used by software tools and hardware tools. So we will teach them to do that. And the third lab actually is where we do the practicals. In the practical, actually, the lab is full of software, free tools. There are a lot of free tools that students can use at home. And there are also actually expensive tools like FTK, Forensic. We have phone logs. We have very expensive tools actually that student can use during the practical.
Thank you so much. We'll take two more questions in the time that we have. Brigitte, there's one question that has come up for you specifically twice. Our attendees are asking, what was the inspiration for you, Brigitte, to have chosen the UK as your study destination, as your international study destination?
Yeah, so as I mentioned before, from high school, I knew that I wanted to take either mechanical engineering or material science. So I was looking for information around about the best universities to actually do that in terms of teaching and research. And then UK itself has some of the top universities in the world. So I look at other aspects, like the time it actually takes to complete the undergraduate. And I realized, like, here in the UK, you only need 3 years, while in the US or other parts of the world, it might take, in general, it would take about 4 years.
Right.
And then the second thing I look at was also the funding or the cost, the total cost it actually takes to complete the undergraduate degree, because it takes shorter time here. Hence, the cost is also a bit lower. So I get the quality, I get the cost, and I get the shorter time. And that's why I chose UK.
Okay, thank you, Brigitte. The last question, I invite all our presenters, all our academics, and Brigitte, for you to share your thoughts. There are some repeat questions bordering on the possibility of students changing their specialization, of moving from one sector towards engineering or information technology for either their postgraduate after having developed a background in, let's say, health or management, and even for their, after postgraduate, a doctoral program. Is that something that's recommended, advised by the academics?
Yes, it is possible. For instance, in the master degree in information technology, half of the class actually have a degree in psychology, in law, and criminology. As I actually mentioned in my presentation, the university provides a lot of support for the student actually to reach the level of technology that is acceptable by the course. We also have things like group work, where students actually work together on a particular project. And then what we do actually, we combine the groups into people who are techie people with other who are not actually, or are less techie people, so they can actually help each other and they can share the understanding. So it is possible actually. We've seen through my career as a lecturer actually, even student actually with a degree in dentistry actually, they managed to finish their PhD in healthcare, which is high tech. So it is possible, yes, with the level of support we provide, yes.
Thank you so much. And to add to what you've just shared, Dr. Ada, all of our presenters have stressed on the importance of and the value of an interdisciplinary program, and how students are exposed to various multidisciplinary courses, and they're given a chance to explore and then finally choose their area of specialization. With that, on behalf of all our attendees, on behalf of the British Council team, I thank all our presenters for today. Thank you so much, Dr. Carl Deva, Dr. Eric Liu, Dr. Mo Ada, Brigitte. It's a pleasure to have had you. And thank you to all our attendees. Thank you for being in the webinar and for sharing your questions and queries. We're sharing this on the screen with you. We have a feedback form and link for you. We request you to please do share your thoughts and ideas, and that will help us design programs based on your interest. With that, thank you so much for today's webinar. Thank you.
Thank you very much, Saman.
Bye-bye.
Pleasure.
Pleasure.
Bye.
Please do send us the link by email.
Definitely. We will.
Thank you very much. Thank you very much. Thanks.
Bye-bye.
Have a nice time, guys.
Thank you.
It was nice meeting you guys. Take care.
Thank you.